you will obtain the other by the other direction, I believe. Okay, so you can see if it's robust or not. And actually here, the minimum here is very deep and bright here, so it's very robust. And so you can extract those kind of tools very easily with just one filtering step. Well, thank you for your attention, and I welcome questions.
Any questions?
Who will be the first one? Thanks, Alexander.
Thanks, Laurent. I appreciate the talk. It was very nice. As far as I understood, that when you build this tree of shapes,
yeah.
So it's always the strategy to convert that into some minimal component tree, like min tree or max tree. So yeah. If it's the strategy, then you can only deal with one attribute per node of the tree of shapes, or could you extend that for multiple attributes, for example?
Well, in the strategy we have proposed there, the way to deal with multiple attributes is to combine them in a unique formula, like an energy formulation, for example, with parameters. And of course, this may not be satisfying, but this is the classical way to deal with level set, for example. And so there is a lot of experience from level sets that can be transferred to that framework. And this is a very good question, because the next step is to deal with different strategies, so different trees, for example, lattice of tree, and try to combine the best information from the lattice. But we don't know exactly how to do that now. Okay. We have some ideas, but
no, I like the idea of applying a functional to the nodes of the tree of shapes. I think it's a clever idea to incorporate more complex, let's say, energy, right?
Yeah.
The other thing is that, have you thought of using some kind of object model for the last part, for example? You could apply that maybe after, over the mean tree, for example.
Yeah, for example, yeah, of course, this is, the attribute is just that, object model. The one I've presented, they are not learned. They are just either an energy function, either attribute like roundness or compactness or whatever. But I imagine that you can, for example, you give to a bunch of students or experts, depending on the situation, they draw what they want, simply lines, black and white. They take a pen and they draw what they want on the sheet of papers, and you can learn to recognize curve, and then you just plug that into the framework, and you will recognize the right curve, the best one among the set of curves you study. Yeah. And this should be very interesting to do also.
Yeah, I found that very, okay, that's nice.
Thank you.
Thank you, congratulations.
Thank you very much.
Any more questions? Okay, I mean, this is a very, very nice comprehensive talk of all your work that you have done over a period of time, and looks like it's a very powerful method, a simple idea you built on, applies on various domains. Now, one of the sensors that's very popular these days is the Microsoft Kinect sensor.
Yes.
Gives you depth. So, do you see some of these ideas being can be applied to those kind of depth data, to clean up, to detect things?
Probably. I haven't thought of that yet, but basically, this kind of method can be applied on any kind of depth image, for example, to look at what you want to find, if they are visible in the image. And so probably, probably they are
applicable.
That's applicable, yes.
Thank you, because those data is very, very noisy, and they are not, I mean, they have holes in there, so some of the ideas that you're talking about should work pretty well.
You can process any kind of data like that, and just if you can design a criterion that will find what you want, hopefully, normally you should obtain something. I hope so.
That's good. Thank you. Any other questions? Well, thank you. Thank you, Dr. Najman.
Thank you very much.